Let us continue with data transformation. We can also do cumulative and rolling aggregates. For example, we know that X is, let's first create an object. So let's say 1 to 10, right? So we know that X is a sequence of numbers from 1 to 10. And if we say lag X, you can see the result at the bottom. It gives us NA and then from 1 to 9. And if I say lead X, it gives me starting from 2 and ending at NA. This basically helps us to offset the results by -1 or +1. We can also do CUM, SUM, which is a cumulative sum. And this gives us the result as 1, 3, 6, 10, 15, 21, 28, 36, 45 and 55. And we can also do a CUM mean that will give us the cumulative mean 1, 1.5, 2, 2.5, 3 and so on and so forth. Alright. Let us look at grouped summaries now. So this is the last key verb that we are using, which is summarize. So if you look at the example, we've already done filter, we have done arrange, we have done mutate, we have done transmute, and now we have grouped summaries. Let's take an example. If I say summarize, what we are trying to do is to summarize a data frame into a single row. For example, flights, the delay is the mean, and then we say NA.rm, which is a logical value indicating whether the NA value should be stripped before the computation proceeds or not. So I do want to do this. I'll keep it as true, and you notice the result comes as 12.6. That means the entire variable departure delay has been reduced to a single row. Now, summarize by itself might not make a lot of sense, because you might wonder, why do I just want to look at one number? Now, summarize is typically paired with group by. So it is paired with group by. And this changes the unit of analysis from the complete data set to individual groups. Let's take an example. So I'll say by day, and this is the object that we are creating, and we are doing a group by flights, year, month and day. We then want to do a summarize in which we will write by day. The delay is equal to the mean of the departure delay, and NA.rm is equal to true. So if you see the result now, it is giving us 2013 1.1 11.5, 2013 1.2 13.9 and so on and so forth. So for every single day, it is giving us this summary. That means it's not giving us all the departures for the 1st of January. It is summarizing all the departures for the 1st of January as a single number, which is 11.5. The group by coupled with summarize is one of the most common tools that you will be working whenever you're working with a data set. Now imagine that we want to explore the relationship between the distance and the average delay for each location. Let's take an example. So we will look at by destination, and let's group it by flights, destination, and then the delay is my summarize by the destination. Let's do a count, which is n. Let's do a distance, which is equal to the mean of my distance. Same thing, na dot rm is equal to true, and once again the delay is the mean of the arrival delay, and na dot rm is equal to true. Alright, now we put the delay as a filter, and we will say that we only want to look at the count, which is, let's say, greater than 20, and the destination is not equal to, this is the not equal to anyone, let's say H and L as an example. Let's run this and see the result. So when I make a ggplot and we put the data as delay, the mapping as an aesthetic mapping, which is x is equal to the distance, and then we have the y is equal to the delay, and on this we also want to add a geom point where we have the aesthetic mapping where the size is equal to the count, and let's also keep an alpha value, so we'll keep the alpha as maybe 1/3, let's say, and then we also want to keep a smooth where we want to keep SE is equal to false. Let's see the result now. So the result comes like this, everyone. And if you look at this, it tells us that we have the distance in the x-axis, the delay on the y-axis, and it seems that delays increase with distance up to 750 miles, this part, and then they start to decrease, which maybe means that as flights get longer, there is more of an ability to make up the delay in the air, right? So when the distance is more, perhaps the flight has an opportunity to reduce the delay which is there. Now there are 3 steps to prepare this data. We had to group the flights by destination, we had to summarize to compute the distance, average, delay and the number of flights, and then we had to filter to only take Honolulu Airport. Now this can be a little frustrating because we have to give each intermediate data frame a name. So if you look at this part, each intermediate data frame had to be given a name. And we don't really care about it, right? And naming is hard because it slows down the speed of our analysis. And this is where we can use the pipe. So the pipe is something we've already used earlier, but we'll use it in this example once again. The pipe looks like this. It's a modulus, then a division and another modulus. So delays, flights, and we will create the pipe like this. Then we will do a group by, and then from the destination we do another pipe like this. We will do a summarize, and we can keep the count as n. We can keep the distance as the mean of distance, where na dot rm is equal to true. Same thing once again. We will say the delay is equal to the mean. Delay is equal to na dot rm is equal to true. And let's close this, put the pipe once again, and now we can filter and say that the count should be more than 20 and the destination should not be equal to H and L. Let's see the result now. Let me just clear everything first. Okay. It says that the object DEST is not found. Let me just quickly see if I've made a mistake somewhere. Everything looks okay. Let me just verify once. So the first one is working, and when we do it here, let's just quickly see, run, and it says the error is there in the group by DEST. Okay, let's see if there's a silly mistake that I made somewhere. So we have the delays, we have the flights, we want to do a group by, okay, this is all right. Then we have done a summarize, we have done the count, this is okay, this is all right. Okay, I'm sorry, I put the wrong symbol, just a minute. Like I said, it's so easy to make these mistakes even after using it so many times. We don't want to use a slash, we want to use a greater than sign. This is how we write in the pipe. Excellent, let's do it once again. And you notice we get the same result as earlier, and I'm sure you would realize that the difference is night and day. Rather than writing all of this, we can simply write a much smaller piece of code. And the advantage here is that we are focusing on the transformation, not on what is being transformed. And that makes the code much, much simpler to read. Let's also look at missing values once again, because this will also be important to you, all of you. So I'm going to take the flights data set. And like we did earlier, we want to create a pipe and group by year, month and day. Let's close this. And then we want to summarize the mean as the mean of the departure delay. So you notice we get the result like this. As you can see, there are a lot of missing values. Now, why is this happening? Because the aggregation functions obey the rule of missing values. That means that if there are any missing values in the input, the output will also have a missing value. Now, this can seem very irritating, but do remember that all aggregation functions do have a na.rm argument, which will remove the missing values prior to the computation. So we just have to make a small addition here. We have to say na.rm is equal to true. And this time you notice we get the correct result like this. Okay. Let's also look at one more example. Not cancelled flights, the pipe, and we will filter is dot na, keep the departure delay is dot na, and we'll keep the arrival delay. We again write not cancelled with a pipe, and then we want to do a group by year, month and day, and then we want to do a summarize, where we keep the mean as the mean of the delay. I hope all of you can see what we have done here. Where missing values represent the cancelled flights, this time we have tackled the problem by first removing all the cancelled flights and then reusing it, right? So this is where we are removing all the cancelled flights and then we are looking at the result like this. Let's look at counts now. Whenever you do an aggregation, it is always a good idea to either include a count or a count of non-missing values. Let's look at an example. Delays not cancelled. So we've already created not cancelled earlier. We want to do a group by the tail num and we do a summarize and the delay is equal to the mean of the arrival delay. Let's create a ggplot. So my data is equal to delays and my mapping is equal to, very simple, x is equal to the delay. And to this we also want to add a frequency polygon where I want to keep my bin width as the any number, let's say 10. And my result now looks like this. And it's remarkable, isn't it? Like this tells you that there are some planes that have an average delay of more than 300 minutes, which is 5 hours. Look here. But you know, the story is a lot more nuanced. Let me explain how. Let's do it once again. And this time we want to look at Rm is equal to na.rm is equal to true, right? And let's also change this to x is equal to n and y is equal to the delay. And we will want to create not a frequency poly, but we will create a point. And let's keep the alpha as 1 by 10. Okay, there seems to be some error. Let me quickly check. So delays not cancel is okay. Group by tail num is okay. We have summarize. Delay, we are doing the mean, and oh, I haven't put the n here. Wait a second. So n, and let's see if there's something else that I have left out. I forgot a comma here. Excellent. Now you notice that, not surprisingly, there is a much greater variation in the average delay when there are few flights. So the shape of this plot is very characteristic. So whenever you plot a mean or a different summary versus the group size, you will see that the variation decreases as the sample size increases. So when you look at this sort of a plot, it is very useful to filter out the groups with the smallest number of observations so that you can see the pattern and less of the extreme variation in the smallest groups. And this is what the following code does. Now I know it's a little bit painful to switch from the pipe back to a plus, but once you get the hang of it, it's quite convenient. Delays. We'll create the pipe. Filter. N is, let's say, greater than 25, and we have another pipe. ggplot, where our mapping is equal to the aesthetic mapping. X is equal to n, and then we have the y is equal to the delay, and we want to create a geom point with my alpha as, let's say, 1 by 10 should be okay. So you notice the result looks like this, and you're able to understand the data in a lot more detail now. All right. Let's see if there's something else that we would like to do. So we have done the mean and the count and the sum, but there are also other useful summary functions, right, that we want to focus on. So we have used mean of x when we also have the median of x. So the mean is the sum divided by the length, and the median is the value where 50% of x is above and 50% is below. Let's take an example. So not cancelled. Let's do a group by year, month and day. We want to summarize where the average daily is equal to the mean of the arrival daily. Just a moment, I forgot a parenthesis here. Yeah, this looks okay. Then we have, let's say, delay 2 is equal to the mean of the arrival delay, and we also want to create arrival delay is greater than 0, like this, which means the average positive delay is what we want to look at. Let's close this. Let's run it and see the result. So you notice the result comes like this. We are using something called subsetting. So this is a more detailed topic, but we will discuss it later, and you can in any case Google it if you want to read more about it. Then we also have the measures of spread, which is we have the interquartile range, the standard deviation, and the standard measure of spread. Let's take an example. Let's just copy this so that I can make some changes. So not cancelled, I want to group by my destination, and then I want to summarize, and we don't need all of this. We'll keep it simple. So we say the distance SD, which is the standard deviation, is equal to SD distance and we also want to arrange in a descending order my distance SD, like this. So we can see the standard deviation here for all the destinations. We also have the measure of position and the measure of rank. So the measure of rank will give us the quantile and the quartiles. Let's take an example. Not cancelled. Pipe. We want to group by the year, the month and the day, and then summarize where first is equal to the minimum departure time, and then we have last, which is equal to the maximum departure time, right, like this. and we get the result like this. Okay, let's see what else we can do. Now, if you want to find out which destinations have the most carriers, you can simply write this. We are looking at not cancelled. We are grouping by the destination and then summarize carriers as n underscore distinct, right? We want to find the unique number of carriers. And when we run this, you get the result like this. So I did not type all of this. I'm just copying and pasting it because by now I hope all of you have understood the basic idea. And we can also do a simple count like this. If you want to keep the weight, let's say the distance is the weight, you can put the weight as the distance and the result comes like this. You might also want to group by multiple variables. So group by multiple variables. Just a moment. So I'm saying that daily is an object where I'm grouping by flights, year, month, day. And then for per day, we are doing a summary of daily flights. Let's see the result now. The result comes like this. The same thing you can do with per month as well. So when you do it with per month, you will get all the months here. And finally, you can do the same thing with per year as well, which will look like this. So we only have 1 year, 2013. So you get 336776. So remember, you have to be careful when you progressively roll up the summaries. It is okay for sum and count, but when you're doing weights of means and variances, it is not possible to do it exactly for a rank-based statistic like the median. In other words, it means that the sum of group-wise sum is the overall sum, but the median of group-wise median is not the overall median. So please keep that in mind. Let's look at ungrouping now. So if you need to remove the grouping and return to operations on ungrouped data, you can simply write ungroup. Let's take an example. So I'm just writing ungroup, which means that I will no longer be grouping by the date. And now you can see the result. It gives a result as 336776. Now grouping is most useful when you use it in conjunction with summarize, but you can even use it with mutate and filter. Let's take an example. So I'm taking my group of year, month, day, and I'm doing a filter rank descending of arrival delay less than 10. Right? So we get the result like this. So these are the worst members of the group. If you want to find the groups that are bigger than a certain threshold, let's say greater than 365, now I can write that popular destination is greater than 365 and the result is, just a moment, popular destination, the result is like this. You can even standardize to compute per group metrics. So here you notice we have the arrival delay divided by the sum of the arrival delay, and we are selecting the year, month and the day, the destination, arrival delay and the prop delay, which is what we created, right? The proportion. And this is the result that you get, the proportion delay. Good. So this was a large lecture where we learned how to work on data transformation. In the next lecture, we will start with something a little different. we will look at EDA, which is exploratory data analysis. Broadly speaking, it's an iterative cycle where we keep on exploring the data till we find out the results that we want. I will see you for the next lecture.